In this video, we are going to look at the very important concept of the derivative. It's a fundamental concept in any calculus course. Now, the derivative of any function really tells us the slope of the tangent line at any point on the function, which will change if the line is a curve. So if we have a straight line, that slope is always the same. But if we have a curve, if I touch a point on the curve here, I might have a positive slope. But over here, I'm going to have perhaps a negative slope. So that's why the derivative can change on any curve. Now, what the derivative tells us is it tells us the slope. It also tells us the velocity of a falling object at any time t. It also tells us the instantaneous rate of change of any function, which can represent many different things depending on what the function represents. But before we talk about the instantaneous rate of change, we're going to talk about the average rate of change. So the average rate of change is really the slope of the secant line. Let's define secant. When you are in geometry, you may have learned that if a line crosses a circle in two different places, it's called a secant line. But if it only crosses the circle in one place, touches the circle, that's a tangent line. So as we look at the average rate of change, we're looking at the slope between two different points on our function. Let's get this down. So in this process, we have 2 points on our curve. We have our blue curve here, and we're going to look at the slope of the secant line, which would be this red line here, which intersects this curve in two different places. Now, if I look at the coordinates on this curve, this point right here has an x-coordinate of a. So if I wrote it as an ordered pair, it'd be a. And the y-coordinate of this is the function value at a, which we call f of a. Similarly, if I move over h units to the right to this point, then at this point, my x value is a plus h, and the y value is f of a plus h, the function value at a plus h. Now, to find the slope, we're going to use that slope formula, which says take y minus y, so f of a plus h minus f of a, over x minus x, which would be a plus h minus a. Cleaning this up, you would see that the a's cancel in your denominator, so you would just be left with h. So our formula for the average rate of change becomes f of a plus h minus f of a over h, when h doesn't equal 0 because your denominator can't equal 0. Let's look at this in an application problem, number 1. Number 1 says, the revenue in dollars from the sale of X plastic planter boxes is given by the function R of X equals 20X minus 0.02X squared. So here again, X is the number of plastic planter boxes sold, and R of X is the revenue in dollars. And here's that function. A asks, what is the change in revenue if the production is changed from 600 planters to 800 planters? So here it's just looking at the difference in the money that you're going to bring in. So let's find R of 600. The R value at 600, it's kind of hard to see, but whatever that would be. To find it, we can plug it into the formula. So we'll have 20 times 600 minus 0.02 times 600 squared. Now, if you plug that into your calculator, you're going to get $4,800. Does that sound about right? If this is 45 and that's 5,000, that could be about 4,800. Then if we want to look, at our revenue at 800 planter boxes, we're going to substitute 800 into the formula. Plugging that into our calculator, we get $3,200. So it wants to know what is the change in revenue. That means we're going to have to subtract these. But if we're going from 600 to 800, here's 800 right here, what's happening to that change in revenue? It's decreasing. So we're going to take R of 800, the revenue from 800 planters, and subtract the revenue from 600 planters. So in this case, that'll be 3,200 minus 4,800, which is going to give us a negative value, a negative 1,600. Now that's what it looks like here. It is moving down. Part B on this question asks us, what is the average rate of change? Now remember, average rate of change is like the slope. So we just found the numerator of our slope. It would be R of 800 minus R of 600 over the 800 minus 600. In this case, we already found our numerator to be a negative $1,600, and our denominator would be 200. So that would give us a negative 8. Negative 8. So let's interpret that, the average rate of change in revenue. So what this would mean is that for each increase in one planter, you're going to lose $8. That would be the average rate of change. Let's write that. So once again, our interpretation is for each additional planter sold beyond 600 planters, revenue will decrease on average by $8 per planter. All right, in the next video, we'll go through a few more examples.